Welcome back, Geometry. We're on for another episode of Math with Mullins. Today, our lesson is 1.2, Measuring and Constructing Segments. Today, what we're going to be able to do is use what we call a ruler postulate. We're going to be able to copy segments and compare them for congruence, also kind of understand what does it mean to be congruent, and then also use the segment addition postulate. First thing we want to cover just some basic vocabulary terms. So we're going to start with this. Postulate 1.1 is the ruler postulate. The points on a line can be matched one-to-one with real numbers. The real number that corresponds to a point is the coordinate of that point. Okay, once we figure that out, then we can figure out that the distance between points A and B, written as AB, is the absolute value of the difference of the coordinates of A and B. So that just means when you find the absolute value of something, that is always going to be positive. And you should have learned this before, but anytime you measure distance, you don't measure distance in a negative way. You always measure it in a positive way. Think about taking steps. If you take 10 steps forward, you've taken 10 steps, and that's going to track on your fitness watch. If you take 10 steps to the side or backwards, then you're still taking those 10 steps. It's not going to deduct the steps that you just took in the opposite direction. Okay. One thing we want to make sure we're doing today is measuring accurately. You're going to be able to do this interactively on your notes today. It's going to be a little bit more challenging for me on the screen. So I'm going to actually just put the answers to whenever you measure it so you can kind of determine, did I measure correctly or not? The last little thing we want to look at before we try any examples is the congruent segments. Congruent segments that have the same length can be written by using this symbol. It's like an equal sign with a little squiggly, and that just means congruent. The lengths are equal, and also the segments are congruent. So one way you can say that, when they're equal, you can say like AB equals CD. But if the segments are congruent, we want to say line AB is congruent to line CD. Okay. So this next point, we're actually going to plot, next part, we're going to plot some points. Keep in mind, these are going up by twos, intervals of two. So we have 0, 2, 4, 6, 8, etc. So when you're plotting these, be very careful. The first point is plot J, K, L, and M. I'm going to go ahead and do that now and just maybe pause this video and press play when you're ready to check your points first. All right, so now that you've got your points plotted, we're going to talk about the distance and congruence here. It says, once you plot these points, determine whether JK and LM are congruent. So first you want to look at JK. J to K is 1, 2, 3, 4, 5 steps apart. So remember, this is at -3 as an x value, and K is at +2. So -3 has a distance from 0 as a +3, and 2 has a distance from 0 as a +2. Sorry, I wrote 3 instead. 3 plus 2 is equal to 5. So JK's length is 5 units. And then I'm going to do the same thing with LM. Now we're going up and down. So that means I need to focus on my y coordinates. Remember, letter L was at 1, 3. So it's 3 above the x-axis, and M is at 1, -2, so it's -2 below, or 2 below the x-axis. Again, the absolute values of these numbers are 3 and 2. We're just counting steps, distance. 3 and 2 makes 5, so are they congruent? Yes. So we're going to write the congruent statement looking like this. Line segment JK is congruent. Use that symbol. It's an equal sign with a little squiggly on top, to LM. Okay. Again, we've got another example here. So let's go ahead and try question 3. Why don't you go ahead and take time now and pause the video here. There's your little pause symbol. When you're done, click play, and then you can start checking your work. All right, here are those points. Make sure you've got them plotted correctly. Now you want to determine if segment AB is congruent to CD. So let's start with AB. Again, remember these are in intervals of 2. That's what a lot of times will trip people up. So make sure that you're counting up by 2s for every line, or a half line would be a 1. Letter A, remember, is at a -2. for its x-coordinate, so that's to the left of the y-axis, and letter B is at a positive 3. So this line is going to be equal to a distance of 5. But if you go and look at CD, C is 2 above the x-axis, D is 2 below the x-axis, so 2 and 2 makes 4. So if you notice that these are not congruent, so what you would say is not congruent here. Okay. Next thing we're going to talk about is a postulate 1.2. So this is like kind of another rule that we're going to focus on and then practice it for the questions below. Postulate 1.2 is the segment addition postulate. That just means if B is between A and C. So I'm a visual person. I'm going to draw a picture. Here is B. Make this a point, my bad. And then it's between A and C. So let's say A is here and C is here. This will make more sense if you can see kind of a picture like this. If B is between A and C, the AB segment plus BC segment will give you A to C. See how easy that is? So if AB plus BC is equal to AC, then B is between A and C, okay? It's just kind of like it feels like a redundant rule, but it's what this segment addition postulate means. So it's proving and reproving the distance between these points, okay? So what we're going to do is just find these simple ones. These are actually very, very simple. So what I'd like for you to do is pause and see if you can try 4, 5, and 6 all by yourself. When you're done and ready to check your work, go ahead and click play. All right, DF, in order to find DF, all we need to do is add DE plus EF. So that'd be 23 plus 35. Really, that's all it is to it. There's nothing crazy about this. So DF, I'm going to write it over here, got a little more space, is equal to 58. Okay. Number 5, find GH. Now this one's a little bit different because GH is a missing piece, but what we have is the entire length. So what we need to do to find GH is take the entire length of 36 and subtract one piece of that, FG, which would be 21. 36 minus 21 is going to give us 15. So GH equals 15. Okay, I'm interested to see how number 6 did for you. I know it's still very simple, but a lot of people get thrown off by this middle ray right here, and that's really not terribly tricky. To find xz, you essentially add your xy plus yz. So xz can be found, I'll pull a tick mark in my z's, because sometimes my z's look like 2's. 23, which would be the xy, plus 50, which is the YZ, okay? Obviously, then 23 plus 50, that's going to give you 73, so XZ is equal to 73. How'd you do? All right, this next one is kind of a continuation from what we just saw in number 6. It says in the diagram, WY is equal to 30. So they're telling us that this is equal to 30. From W here to Y. Okay, can you use the segment addition postulate to find the distance between points W and Z? So W is here, Z would be here. So this line right here. Maybe pause, take a moment, see if you can answer and explain your reasoning. And when you're ready, click play to come back. So the answer for this one is no. And the reason why is WZ is not collinear. The only way that the segment addition postulate happens is if they are in a line or on the same line, okay? And really, in fact, W, Y, and Z, those are all kind of like important numbers or important points because we know WY is 30, we know YZ is 50, but WZ can't work. And we're actually going to learn a little bit more of that starting tomorrow. Okay. Let's go on to number 8. Again, go ahead and take time now to pause the video, use this diagram to find KL, and when you're done, click play. So KL is pretty simple. You're just taking your 144, which is JL, and subtracting 37 from it, which is segment JK. So when you subtract those, you get 107. And last but not least, we have question 9. These cities on the map lie approximately in a straight line. That's important. We can only use this postulate if they are in a line, a straight line. Find the distance from Albuquerque, New Mexico to Provo, Utah. So here's Albuquerque, here's Provo. Notice that's the missing piece of the segment. We do have the total, which was 680 distance from Carlsbad to Provo, but now we just need to subtract that 231 to figure out our leftover amount. So from point P, which is Provo, to Albuquerque A is 449 miles. Okay. That is going to be the conclusion of our notes today. Thanks so much for tuning in for lesson 1.2, and we'll catch you next time.